Hey everyone, Puneet here. Welcome back to the North of Patient podcast, conversations on health beyond care. This week's guest is the remarkable Dr. Suzanne Gildert. She's a physicist, artist, and AI tech executive based in Vancouver on a mission to uncover the mysteries of consciousness and innovate unconscious AI. She's CEO and founder of Nirvanic Consciousness Technologies, a quantum AI deep tech startup focused on unlocking the computational power of consciousness. Suzanne's journey blends academia, entrepreneurship, and cutting edge technology. She previously founded Kindred AI and Sanctuary AI, two groundbreaking robotics companies here in Canada. From her early fascination with quantum mechanics, drawing from the great minds of the 1920s and the 1930s, to her love for electronics as a child, these passions shaped her path to a career in physics and pioneering quantum computing and D-Wave systems. She later co-founded Kindred AI, where she addressed the challenges of building general-purpose robotics and exploring how AI can emulate human intelligence. In this episode, we explore some of the most significant breakthroughs and challenges in quantum computing and the transformative potential of these technologies to reshape our world. But we don't stop at the science. We also delve into the philosophical questions surrounding consciousness. In healthcare, we render patients unconscious for procedures and surgeries and bring them back to consciousness all the time. But what does this really mean? And what other states of consciousness might there be? Truthfully, we know little about consciousness altogether, and as a result, we have a limited understanding of how it intersects with both health and illness. We also discuss the ethical and philosophical dimensions of AI consciousness, questioning whether AI can ever truly replicate human experience and identity. Suzanne's personal journey from strict materialism to embracing the interplay between science and spirituality adds a deeply introspective layer to the conversation that we have. So, settle in for an engaging and thought-provoking episode. The links to the full conversation are in the comments below. North of Patient is on Spotify, Apple Podcasts, YouTube, and Substack. Don't forget to subscribe on Substack and follow along. As always, I welcome your comments and ideas, plus suggestions for future guests. Without further ado, here's episode 13 with Suzanne Gildert. Suzanne, so wonderful to have you here at North of Patient. I just want to say I'm deeply appreciative of you taking the time out of your busy schedule to have this conversation. There's so many things that I've been wanting to talk to you about and ask you about, but I want to start off just by saying grateful for your time.
Oh,
Welcome to the show.
thanks so much for the opportunity. I'm really excited about the conversation today.
Yeah, so diving right into kind of getting an understanding of the very interesting arc of your career, maybe do you want to first just tell us a little bit about your career journey that led us to where you are today, which is CEO of Nirvanic AI?
Yeah, sure. So I've always had an interest in science since I was a little kid. And I studied physics and electronics at university in the UK. And then I specialized and did a PhD in quantum physics. And at that time, I wanted to leave academia and work in industry, so building systems at scale. But really, the only quantum physics company or quantum computing company in the whole world was D-Wave Systems here in Vancouver, in Canada. So I moved from the UK to Canada in 2010 and joined that company. And then I started programming quantum computers as my job. And I was looking at how to apply them to various problems, including in AI. And this was before AI really became a big deal. It was back in the early days of what people would now recognize as AI. So I was programming these quantum computers to try and improve AI. And I got really interested in the field of artificial intelligence and robotics from doing that. So in 2014, I founded my first startup, Kindred AI. And I did that for several years. It was very successful. We released a robotic product that worked in warehouses. And then in 2018, I left Kindred and founded Sanctuary AI. And the idea there was to take some similar ideas, but apply them to general purpose humanoid robots. So we were trying to build, again, something that was a bit ahead of its time. There were no humanoid robots at that point, and now there's actually quite a few companies that are doing that. Through building humanoid robots and trying to give them minds like people, I started realizing that there was a big open question around what is consciousness. And it's still not clear today whether AI is conscious, whether it ever will be conscious, and what that means for our society and for our interaction with AI systems. So again, I left Sanctuary and started a new startup, Nirvanic AI, or Nirvanic Consciousness Technologies, as it's called formally. And the role of this company is to try and understand that link between AI, ourselves, and where consciousness fits into the picture.
First of all, lots to unpack there. Congratulations, obviously, on your storied successes over the years. Maybe just starting at a little bit of the basics for the uninitiated. We don't need to go too deep into this, but can you explain what quantum computing is for the non-technical listener?
Right. Yeah, so everyone's familiar with their own desktop computer or their cell phone and kind of vaguely aware that it kind of does mathematical, logical computation under the hood. So it's manipulating zeros and ones to do everything that we see our machines doing. Quantum computers, they do kind of the same thing, but instead of using zeros and ones like bits, they use something called qubits. So you're fundamentally changing the bit that you're using from a 0, 1 to something that can be a 0 and a 1 at the same time, and can also interact with the other zeros and ones in a strange and interesting way, which some people think of as a spooky quality of quantum physics. So you're really going in at the lowest level and changing the definition of what a bit is in your computer. And what that allows is, when you change the definition of what a bit is, it allows you to do certain computations much faster. And potentially, we haven't even uncovered yet all the potential applications of what could be done faster, what could be done better.
Mhm. And as I understand, there's some pretty significant limitations in terms of being able to perform quantum computing. Obviously, in recent news was Google's big announcement. I actually understand the paper was published several months ago, but more recent, there's been some media coverage around it, but with Willow. Um, can you speak a little bit about what sort of limitations currently exist in terms of how we can actually build these types of powerful computers?
Yeah. Yeah, so again, it's kind of an emerging, changing, ever-changing field. It's getting better all the time, but the two main limitations at the moment are the scale of the systems. So when we look at a modern processor, it has billions of transistors inside it, whereas a quantum computer only has hundreds or thousands of these little devices that are called qubits. So really that's just a scaling thing. It's just going to take several years to get the number of qubits higher. But the other main problem is what's called error correction. So this is like how accurate is the computation that you're doing? How accurate is that qubit? So imagine you had a calculator and every so often you put 2 plus 2 and it gave 5. That's not a very good calculator. So quantum
Yeah.
computers are a bit like that at the moment. Like, most of the time they give 2 plus 2 equals 4, but sometimes they'll get it wrong. So what people are trying to do now is come up with what's called error correction to get rid of those cases where it gives 2 plus 2 equals 5. And so the big Google announcement is we're getting closer to that threshold of getting rid of all those little errors. And so that's why this was such a big deal, because you don't want to scale a system and build millions of qubits if they're all giving the wrong answer, right?
Mhm. And I understand there's also some type of temperature related limitation to where these computers can function or where they're developed. Can you briefly speak to that?
Yeah, so again, it depends on the type of quantum computer. So the one that Google builds and several other companies is called a superconducting quantum computer. So this uses it's similar to silicon technology, but with different uses different metals, and they cool it right down to near absolute zero. And that's where the quantum effects start to show up. But there are other types of quantum computers that use photons, like kind of lasers and things like that, that don't have the temperature requirement. There's another one where you can trap individual ions in a substrate, and you can manipulate the ions and what they're doing. So those also don't need to be cooled. So really the superconducting ones are the ones people hear about that need the very cold temperatures. And again, the technology for achieving and sustaining those cold temperatures is increasing and improving as well. But yeah, there's lots of different types of quantum computers out there.
Gotcha. And so just in speaking to your own journey, kind of coming into quantum computing, was there something in particular that spoke to you about the technology? Like what drew you to it to begin with?
Well, I've always had an interest in electronics since I was a little kid because I did hobby electronics with my dad. He was interested in amateur radio and stuff like that. So that kind of like set the baseline. But then I really
Hmm.
got interested in the quantum part of it when I had a teacher in high school that taught us all about the early days of quantum mechanics back in the 1920s and the 1930s when the theory was just
Hmm.
starting to emerge. And there were these like giants like Schrodinger, Niels Bohr, all these like kind of great founding fathers of quantum mechanics. And so she taught quantum mechanics in a way where these amazing scientists didn't understand what was going on. There were all these open, interesting philosophical questions. Quantum mechanics is really spooky and weird, and we don't understand it. And I think that just really kind of sparked my interest. And it was the first time as a student of science that I realized scientists don't have all the answers. So I think that's
Hmm.
what really kind of got me interested there. You think when you're learning science in school, you're just learning something that everyone knows about already and it's already been figured out. But then you start to realize, no, there are places in science where we absolutely have no idea what's going on yet. And to me, that was fascinating.
You're right. Like it certainly seems like it's one of those places where there is still very much an open frontier. And as I understand it, it also challenges so many of our existing notions about what we understand about physics. So
Yeah.
it's incredibly fascinating. I remember in kind of reading about your career, there was a reference to a game that you'd actually developed called
Yeah.
Max Cat, which I understand was one of the first kind of quantum computing based games. Can you speak a little bit about that?
Yeah, I think it was the first game that you could practically play with a quantum computer. So, really, I developed the game as an educational tool because at the time I was working in kind of technical sales and marketing. So, I was trying to find ways to explain how the quantum computer worked to sometimes completely non technical people. So, I developed a game which was the quantum computer and how these bits I talked about were connected to each other. I turned it into kind of like a game board. Imagine it's a bit like Risk. So each
Hmm.
quantum unit is a different territory and they're connected to each other, so they share borders. And then the idea was you have these cards, a bit like Pokemon cards, and they had cats on them, and that was because of the Schrodinger's cat analogy there, where each of the cats could be in the state of alive and dead at the same time. So you had to play these cards onto the different territories and try and turn all the cats alive whilst the opponent was trying to turn them all into zombie cats. So it was really a way of describing like how the quantum computer worked in detail, but it was a sort of fun like novel way of explaining that.
That's incredible. Is this game still available, or was it?
It's actually not like I developed it as an internal kind of educational tool, but I always keep thinking maybe one day I'll turn it into an actual game because
Yeah.
it's just fun. Yeah.
So, so kind of going from quantum computing and then eventually to your first startup, Kindred AI. Can you talk about what led you to want to then explore, general purpose robotics? What was the transition and what was the inspiration behind that?
Yeah, so the inspiration was while I was working at D-Wave, we were trying to find applications for the quantum computer. And one of the applications was in AI learning algorithms that learned from data. So people had been running the algorithms that were around at that time on things like images, video, and audio and a bit of text. Like this was before the large language model and the GPT. So imagine totally before any of that came along. People were mostly looking at training things on a little like image data sets and things like that. So what I was wondering was whether we could apply these same AI techniques to data coming from a robotic system, which would have a movement or a motor component to the data. And the thinking was if you can learn from a data set that consists of input data like perception and actuator data like motor output, then you have all the data needed for a complete what's called embodiment feedback loop. So think of it as you've got a robot body, it's got data coming into its sensors, and it has a way to act on the world. So if you
Mhm.
can train on all that data together, then it's like maybe you could get the robot to act in the world in the same way a person does. So that was sort of the idea. It was like expanding the types of data people were looking at to encompass all the
Mhm.
types of data that we find in our own body, at least, from the movement and the perception side. of things. And so that's where I started getting interested in robotics. And I always thought, if you could build a robot system that mimicked all of our input data and mimicked all of our output data, then in theory you could build a mind that worked like a person. So little did I know there was this thorny issue of consciousness, which I was sort of ignoring at the time, because I used to be a very strong, what's called materialist, atheist type person. I used to believe everything could be explained by mathematical equations and our mind was just computation. And so if we had enough data, we could simulate the human mind. But I'm not sure I believe that anymore.
Fascinating. And we can dive into that a little bit more as
Yeah.
we get closer to the story around Nirvanic AI. But thinking about Kindred AI and the application of those robots, what sort of um, applications did those robots have in functional utility, and were there ever any intersections with healthcare or thought or thinking around how this might be used in healthcare?
Yeah. So we thought a bit early on about some healthcare applications, because when we started Kindred, we wanted to build general purpose robots that could do many, many different tasks, including tasks in healthcare and in providing like medical care for people. What happened at Kindred though was it was very early. That was in the very early days of robotics and AI. So we ended up having to specialize the product into a warehouse e-commerce type application, where the robots were essentially picking and placing goods. So an e-commerce order would come in and then a robot would have to select the right items from a giant batch of everyone's orders and kind of put them into the right customer orders. So it was like a order fulfillment sortation product. And so one of the reasons I kind of wanted to go and found Sanctuary after that was I found that product, while it was very successful and a very cool project to work on technologically, it didn't have that aspect that I'm fascinated by, which is the general purpose nature of it. So it didn't have that idea of a robot that could then go and be used in healthcare as well. So it kind of got like into a warehousing niche. And I thought, okay, maybe there's a way we could use this technology to go after more general applications.
And that's often the case, obviously, with entrepreneurial journeys, which is that you try to find there's like the aspiration and then there's the business sustainability in reality.
Yeah.
And I can appreciate that sometimes you end up kind of going down that direction. Yet there's still that longing to do the thing that you kind of originally wanted to do.
That's right. That's right. Yeah. I call
Um,
it pivot to stay on track. So,
yeah,
often an entrepreneur might look like they're going all over the place. They create one
yeah,
company and they apparently change direction, but usually what's actually happening is they have some deep underlying mission that they're really trying to get at and they've created a cool product, but now they need to get back to
yeah,
that initial mission idea.
absolutely. So, with Sanctuary AI, can you talk a little bit about, again, what kind of advancements took place in general purpose robotics, and did it get to the place where it can be applied in healthcare, or there are healthcare specific applications?
Yes. So at Sanctuary, we decided to double down on the humanoid form factor. And again, this was back in 2018. So no one was really doing this. Maybe like there were Boston Dynamics and a couple of other companies that were looking at it, but it wasn't popular or no one had really heard of humanoids at that time. So that was our golden rule, is we're going to stick to the human-like form factor, because then we'll improve the AI and it will probably start by doing narrow tasks, but because it's got that form factor, it has the capability to then do any human task. And I had a lot of people ask me, why build humanoid robots, right? Why not build a robot that's special, like purpose made for the task? And the reason really is the world is designed for humans. It's designed for people, our form factor, everything we interact with, from chairs to ovens. It's designed for our human body. So the idea is, if you can create a robot that mimics that form factor, then it in principle can do any task. So we built that at Sanctuary, and Sanctuary's still kind of like working on that technology and improving it and deploying it into situations. I don't work there anymore, but when I did, we were talking to Magna and talking about those robots working in automotive manufacturing. So to me, that's kind of like the first task, is getting these robots out there, getting them deployed, getting them doing tasks in factory or kind of manufacturing jobs. And then from there, once they've been proven to work well and be able to do these tasks, they start moving out into the wider world. And that's where it starts to intersect with healthcare. Because you could
Mhm.
imagine taking a humanoid robot, not necessarily a sanctuary one, but just any humanoid robot. And then if you have enough training data and enough smart AI on the back end, it could learn to start doing tasks in healthcare. Actually, one
Mhm.
project we worked on early at Sanctuary was a healthcare related project. This was during the pandemic. We looked at
Mhm.
whether robots could actually be used as like a telemedicine interface
Mhm.
for doctors, for general practitioners. So imagine you could basically see the robot doctor, but your GP would be
Mhm.
behind the scenes controlling the robot. So
Mhm.
obviously, this kind of sounds crazy now, but during the pandemic, it was like really no one wanted to have, it's all social distancing and everyone was worried about kind of people being close to other people. So this was one of the things we looked at. And I think that idea is still interesting, the idea of having like a robot doctor. And initially it is teleoperated by a person behind the scenes, but then slowly over time, as it gets better, as the AI learns more, it can become more autonomous.
Mhm. Yeah, and I mean, the obvious things that come to mind is obviously, robot-based vaccine administration,
Yeah,
where you want to you want to make it scalable. You could have these robots deployed into rural regions, or
yeah,
effectively go on
absolutely.
tour, if you will,
Yeah,
being able to do that,
that's
24
right.
hours a day or whatever the
Yeah.
case may be.
And the other cool thing
That
is you
that
could have your robot, and maybe it's like the GP is the one that normally controls it, but if you need to bring a specialist in, then you could have a bunch of specialists on call that essentially, once a patient has had an initial diagnosis, the expert could jump right in now and see the patient
Mhm.
instead of them having to then go on a wait list and maybe wait months and months, or not even be able to see a specialist at all because they're in such a remote area. Yeah.
That's true, and given that the specialist in that context doesn't need to be there in person, they could be dialing in from anywhere
Yeah,
within
anywhere in
global
the world.
network. And
That's right.
yeah. So thinking about kind of the human robot sort of interface, and this idea of humanoid robots versus non-humanoid robots. As somebody obviously outside of this specific industry, but as a science fiction fan myself, and I've made a few trips to Japan, and I'm always taken by the extent to which robots of various kinds are integrated into society. I often find that in Japan, I notice a lot of the times they're often not in a human form, um, but at the same time, there seems to be an incredible amount of interactivity, and the interface between people culturally and these robots seems to be actually quite profound. Can you speak a little bit about that and your thoughts about kind of um, non-humanoid robots and kind of culturally the interaction between those?
Yeah, so this is super fascinating because it gets into some of the topics I'm sure we'll talk about a bit later, which is like the
Mm.
consciousness and stuff. So, how someone interacts with a robot, whether they bond with the robot or not, is much more about the human robot interaction. So, it's a bit like if you're designing a character for a movie and the character is non-human, like it's kind of a little machine, or like Wally or Baymax or something like that. It's about how it interacts, it's about its mannerisms, its gestures, and sometimes these systems don't even speak, so there's no language component. So, really, if you want people to bond with robots, you have to turn them into kind of lovable characters. And there are
Mhm.
people trying to do that. Now, the question is, how do you do it? Because a lot of the character based AI at the moment is, I'm going to sound bad saying this, but it's like fake. A lot of
Yeah.
it's very scripted. And so you can have a really cool interaction, but it's often very structured or very scripted. If you want an open ended interaction with a robot that has that robot coming across as really caring, really being empathetic, really wanting to get to know you. We don't have any technology like that at the moment, I think, that could really fit the bill. I think for systems like that to work, they're going to have to be truly conscious. And so I think, yes, you can make a non human like robot really bond with you, but I think it really has to start getting into the realm of whether it's conscious or not, like a dog or a cat might be.
In reference to kind of TV shows and popular fiction as well, have you seen the TV series Sunny?
I have not.
Um,
No.
Yeah, that's an interesting one. I think it came out within the last couple of years, but basically talks about a woman who lives in Japan. Actually, I won't give away too
Okay.
much of the actual plot line, but in general, it's about a human robot interactivity and actually the pretty deep connection that she forms with this robot who appears when her husband passes away. That concept is definitely very interesting, and maybe this is a good segue to begin to talk about a bit of that deeper connection and the evolution beyond the robot itself. But moving on, I guess, to Nirvanic AI and the inspiration behind that, can you talk a little bit about that journey?
Yeah, so I've been building robotics and I guess AI mind solutions for them for a long time. So my dream and my like passion has always been to try and figure out what's going on inside the human mind and then how can we use that to improve our interaction with machines and also have robotic machines that are able to do lots of things for us. During my previous companies, I've really focused on whether the robot is physically capable of doing things. So, can it move objects around? Can it understand the environment? You know, things like can it open the door of a refrigerator? And so, most of what I focused on is getting it to do like these routine tasks that we would find trivial. Like knowing what an object is and where it is something that's very hard for a robot. We
Hmm.
take it for granted that we just look around and we see things like, you know, our computer mouse and some headphones and like a picture frame. And it's like AI and robots do not see the world like that. They see a bunch of
Hmm.
pixels. They do not see things. So you have to train them. It takes a lot of effort just to get an AI to that point. And then to get it to the point where it can not just see a cup and identify it, but then know how to move its hand and actually move and coordinate all the fingers and then grab the cup and put it somewhere else. That's actually a really complicated task. So there's this thing in AI called Moravec's paradox, which is like the things we think of as really easy, like picking up a cup and moving it somewhere, is really hard for robotics and AI. And
Hmm.
things that we think of as really hard, like playing chess at a super high level, is ends up being a much easier problem to
Hmm.
solve in AI.
Yeah,
So these
yeah,
things that a toddler could do are still even today very difficult for AI systems.
yeah. We talk about folding laundry as one of those
Yeah,
examples, right?
folding laundry. And there's still really no system that can kind of just learn to do that from scratch by exploring or playing around like a toddler would. We have to show these systems what to do with large amounts of what's called training data. So if you want a robot to fold your laundry, you essentially, the only way to do this is to teleoperate the robot, fold laundry as a person, like you through the robot interface, millions and millions of times, and then you train an AI to sort of mimic that. So this is
Hmm.
the state of the art of how this is done now. And the idea is if we had millions of robots with maybe thousands or millions of humans teleoperating them, then we can get
Hmm.
enough training data to automate tasks in a general way. The problem with this is
Hmm.
it's a really difficult problem to scale because you need so much data. Like
Hmm.
here's a good way of thinking about it for people that maybe aren't in the field of AI. So everyone's heard of ChatGPT, most people use it, or Gemini, or some other copilot, some other kind of like system. To train those types of AI systems takes the entirety of the internet worth of
Hmm.
data and just amazing amount of energy, amazing amount of compute. It takes like kind of
Hmm.
giant super clusters now to train those models. That is just text, right? So
Hmm.
that is just words. It's like just the alphabet characters. Now
Yeah.
imagine you're not now just learning alphabet characters, you're learning vision, you're learning audio, you're learning touch, you're learning movement
Hmm.
in the real world in a robot. The scale of data that you need to include all that extra information, it just becomes ridiculous. So
Hmm.
it's possible to learn simple tasks one by one using that approach, but I'm
Hmm.
not sure it will scale to
Hmm.
full generality.
That's a fantastic point. What are your thoughts in that setting where obviously different companies are taking different approaches to that? So in the context, let's say, for example, robotics or self-driving cars, there's obviously kind of the Waymo versus kind of Tesla approach to that. So do you think that in that case, it can be said that because of the way in which data is being captured, let's say on the part of Tesla, as I understand it, the approach is a little bit more capture as much data as you can. with Tesla vehicles on the road and the cameras and the sensors, and then use that to be able to simulate driving. Versus, as I understand it, on the Waymo side, it's much more about being able to actually create models that are specific to the functions and understand the rules of the road. What is your thought about those two approaches? Are you in one band camp or the other?
I think both can work.
Yeah.
It's been shown that just increasing the amount of data eventually will work. So I guess
Mhm.
really whether one works or the other is kind of a nuance of exactly how good the sort of more structured modular method works versus just throwing lots and lots of data at it. So it's really difficult to know, but it's been shown that if you just keep getting more and more and more data, eventually it will work. So then it's a question of how
Mhm.
much data do you need, and can you get that? So self-driving cars is a really interesting application because it's sort of in the middle of what I'm talking about. So training text models is a sort of limiting case where the data is fairly simple. And then what I'm talking about with a robot that has to work in a general environment, like a humanoid, that's at the other end of the scale. And self-driving cars are kind of somewhere in the middle. So the problem of driving is more complicated than the text, but it's not quite as complicated as a fully unstructured environment that a robot has to walk around in. So it'll be a really interesting case to see if self-driving kind of scales to be fully autonomous, because that gives us an
Mhm.
idea of how hard the next problem is, which is the humanoid in the home problem.
Yeah. So, how does this then extend into the consciousness conversation? Can you begin to speak a little bit more about where does data fit into this, or I guess even at a more basic level, what is consciousness, and then what is quantum consciousness?
So people have lots of different definitions, by the way, for consciousness. So one of the things I'm trying to do is come up with a strong definition at Nirvanic that we can then build on. So not everyone might agree with my definition of consciousness. So I define it as kind of having two main aspects to it. There are some others, but the first one is having a first person experience of the world. So it feels like something to be you, and you can shift that experience around. So what you're conscious of at any one point can change. So I can like focus my consciousness, you know, or maybe when I'm reading a book, I'm focusing my consciousness on the text and I've forgotten about everything else that's going on around me. So that idea of having this like subjective experience, it seems like data is somehow loaded into an observer that then watches a movie playing out around you. That's kind of the first part. And then the second part of what I think consciousness is that movie that's playing out in your, like the theater of your mind, if you like, is
Mhm.
the information from that is now used to present options or choices to you. So imagine the movie becomes a choose your own adventure movie, or it's like
Mhm.
interactive, like a video game where you now have choices about what you can do. So this sense or this feeling we have of having a choice or choosing, some people call it free will. That's kind of
Mhm.
like the big second part of consciousness. So I believe, and again, not everyone believes this, so this is just my viewpoint, but I don't think AI is conscious in that same way right now. I don't think any AI system we've built today has a sense of experiencing the world. And I
Mhm.
also don't think it has this sense of free will, or it has this sense of the ability to choose between multiple options. So the way I
Mhm.
think AI works is it just takes in data, it crunches that data mathematically, and it just outputs an action based on what it's seen before. So
Mhm.
the reason this is super fascinating and related to consciousness is our brains also do this. So if you think about unconscious behavior where we're not conscious of doing something, like if we've been driving for 20 years, we're actually not conscious of driving anymore. We just do it. So
Mhm.
our brain can operate in two modes. One is what I call unconscious or subconscious operation, where you're doing things without being consciously aware of it. And then there's conscious operation where you actually feel like you're experiencing it and you have this ability to choose. So I think AI all falls into that first bucket. Now that doesn't mean it's not useful, because you know driving on autopilot is very useful for people, right? Doing
Mhm.
doing tasks on autopilot all day is very useful, but it's different from this part where consciousness seems to step in. And so these two different buckets of operation, one where it's unconscious, is this case where you've seen lots and lots and lots of training data before, just like an
Mhm.
AI. But what I think AI needs is a second mode, where you're in an unfamiliar situation, something novel is happening that you've never experienced before. You become hyper aware, you become conscious of what's going on, and then you're able to make intuitive decisions about what to do.
Mhm.
So it's a lot to take in all at once.
Yeah.
But this is where I think consciousness comes in. It gives AI a second mode to fall back on if it's in a situation where it's never seen any training data before.
Mhm. Okay, so just unpacking that a little bit further. So as you defined it, it's the ability for to become aware, focus its attention, if you will, on a specific area,
Mm-hmm.
and then to be able to, through that hyper awareness, choose to make specific actions in that environment. I guess as an extension to that, would you say that there's belief right now amongst any part of the scientific community that that may already be happening? Are there scientists who believe that we may have already done that, or there's kind of some self-awareness already there?
Yeah, I mean, some people believe this. It's
Mhm.
I wouldn't say it's 50%, but maybe, I don't know, maybe 20 to 30% of people believe this
Okay.
just based on like little polls and anecdotal stuff I've kind of done over the last year or so. I think a few
Yeah.
people do believe it's already conscious. That there's also a whole bunch of people that don't think consciousness exists, so they think it's not real
Mhm.
or it's some kind of illusion, which I find
Mhm.
crazy because it's like everything we experience is our consciousness. So how can you say it's not real? But anyway,
Mhm.
I think yeah, there are some people that believe AI is already conscious, already self-aware. The problem now comes to how do you prove it? So I
Mhm.
can't really even prove you're conscious. So how
Mhm.
am I proving an AI is conscious? There's no real test. So in people, we can put them in, scanners. We can look at EEG. We can look at what's going on, fMRI in their brain, and we have these sort of correlates of consciousness. So you can look at a human brain and at least have a very good guess as to whether that person is conscious or not. And people use this for things like lock-in syndrome to know if someone's
Yeah.
actually there. Also, when you're anesthetizing someone, you want to know that they're actually fully
Yeah.
unconscious. So we do have ways to test in people, but when it comes to AI now, an AI's neural net is completely different from the human brain. So we have no similar tests for an AI. So it's really just these people that say AI is conscious. It's kind of just a hunch at the moment or a
Mhm.
feeling they get from what the AI is saying to them. But I
Mhm.
don't buy that at all because if you're reading a really good novel and the character says they're conscious and they make you feel emotionally connected to them, that doesn't mean they're a real conscious person. So I think
Mhm.
AI is just very cleverly mimicking saying that
Consciousness. Yeah.
it's conscious when it actually isn't. Yeah.
Mhm. Then I guess the next question before we talk about some of the ethics around this,
Mm-hmm.
because there's the whole other ethical conversation. So how does one explore this conversation further, and how does that translate into your research and work?
Mm-hmm. Yeah. So we really need to understand what consciousness is and how it works in humans and in other animals, I think, before we can really say a lot about AI. So what I'm interested in at the moment are unusual theories of consciousness. And the one I'm specifically looking at the moment is what's called quantum theories of consciousness. So I have a background in quantum computing, so I'm obviously predisposed to be interested in this. But there are
Mhm.
some actually growing number of scientists that are finding evidence for quantum effects in the human brain, and also a growing number of philosopher scientists who have a theory of how some of these odd properties of quantum mechanics that I mentioned before could explain some of the properties of our mind, like the sense of free will and feeling like we are able to choose, and the experience of the world, what's called qualia, can be explained by some of these quantum properties. So there's sort of a mounting body of evidence that what's going on in our mind could be explained by quantum theory. And that's what I'm trying to explore, both theoretically and practically, by trying to build a system whose mind computation works on a quantum computer rather than a classical computer like AI does.
Okay. And are you able to speak to, I guess, more details about how you're doing that, or what does that experiment look like?
Yeah, so well, I can't go into too much of the details of the algorithms yet in
Of
detail
course.
because they're still being developed. But The basic idea is you take in information from the environment. So again, this is like the way most AI systems or embodied AI systems work, taking data through sensors. You then take that data and you load it into a quantum state. So you take it from the classical realm where it's zeros and ones, and you turn it into quantum information. You then kind of massage or evolve that quantum state so that what happens is it comes up with different action options that the system could choose. So you have a sort of function that takes input perception, turns it into action options, and then the quantum system goes through something called collapse or measurement. So in quantum mechanics, many people may have heard that a system, once you measure a system or once you observe a system, it changes into a definite value. So it kind of like chooses which state to end up in. So you measure the quantum system and then it essentially chooses an action. And then you use that action to, do something with your AI, whether it's an agentic system or whether it's a robot. You actually then execute that action in the real world.
Mhm. And in this case, I'm assuming that action happens through robotics in terms of the experiment.
It can be. So I'm trying to keep it as broad as possible because this could apply to any kind of AI, but anything where a system has to have an action output. So that could be a robot, which is an obvious example, but it could also be a system that's, so a lot of what's been in the news lately is these kind of like browser control AI systems where an AI literally takes control of your mouse and keyboard and it can like click around, do things for you. So that's another example of a kind of action, which is acting more on a user interface or a software level.
And I can appreciate it's obviously very hard to kind of speculate or guess at this point, but if you had to say in your mind what that arc looks like in terms of when we begin to either have answers or begin to, even outside of the realm of kind of quantum consciousness, when we begin to get to a place where you feel like conscious AI could be a
Mm-hmm.
possibility, how far away is that? What does that look like?
Mm-hmm. Yeah, there's still many open scientific questions and underlying this. So the answer really is we're not sure. I really don't like putting timelines on things because
Yeah,
then
no,
people hold me
I
to
get,
them. But
yeah.
what I'm hoping in the best case scenario is, within the next like year to 2 years, we have big enough quantum computing systems and we've come up with smart enough experiments to start seeing little signatures of this. So by no means will we have a conscious system anything like our own consciousness, but we might have
Mhm.
something that has a spark of conscious decision making such that it's making slightly smarter choices than its unconscious AI companion, right?
Mhm.
So I'm hoping that there'll be a signature there that we can actually detect and measure. And that's like what I'm
Mhm.
looking for at the moment in these early scientific experiments is can you see a signature of a smart decision choice being made? And you might say, how do you even know it's made a smart decision? Well, if you think about an AI system before it's been trained at all, then it's going to choose actions at random because it doesn't know anything.
Mhm.
So what I think of as a smart decision is that the quantum system chooses an action that's slightly better than random without having
Mhm.
seen as much training data. So that's kind of what we're looking for. It's like it's learning faster, it's making slightly more intuitive, smarter decisions than what an AI would with a lot less training data.
I guess how big of a question is this in terms of how many people are exploring this? Is this extremely niche? Is this something that's pretty distributed? How would you qualify that?
Yeah, I'd say it's extremely niche at the moment.
Yeah.
There's probably, I mean, okay, there's a lot of people around the world that explore, that do consciousness research. So that's quite a big field, actually. But then
Mhm.
the number of people that do quantum consciousness research is much smaller now. So now you're talking maybe hundreds to thousands of people around the whole world that do this. And then the number of
Mhm.
people that are actually trying to build it or practically experimentally test it is now down to like, I'd put that in the maybe 10, maybe less than 10 people around the
Wow.
world. But the reason I find this stuff so fascinating is the following. So imagine you're a tech entrepreneur and you're trying to get, a foothold in the world. So you can start a company in a field that everyone else is already working in and then try and find some kind of little differentiated edge. And that becomes very, very, very tricky, especially in AI, because now you're competing with the big tech giants. It's very,
Mhm.
very hard. But if you're someone like me that wants to start something like 10 years too early, then you essentially have a green field of opportunity because no one else is doing this yet. So what that means is you can hire people really easily because all the people around the world that are interested in this thing will want to get involved because no one else is doing it. No big companies are working on it. And then also you can get a good position early on. You can get like a good IP position. You can get some good innovations, good inventions early on. And then if it turns out to be the next big thing in like 5 years' time, then you're in a really good position. So it's just a personal choice, but as a kind of entrepreneur, I like to work at that really, really early cutting edge curve that's way before you're trying to commercialize something way before it's really ready. But by doing so, you build this really strong foundation that like when that wave does start to come, then you have a really strong position in the field.
That totally makes sense, right? And it gives you an incredible foundational edge, as you mentioned there. Um, so, kind of thinking about this from a more applied sense in the
Yeah.
context of even, let's say, healthcare, and I appreciate this is very speculative at this point,
Yeah.
but I'm sure as somebody who's thinking about this and working on this daily, what thoughts have you had about
Mm-hmm.
the implications of this on the experience of human health and
Mm-hmm.
healthcare in general?
Yeah.
Is there anything you can share about what you think this could mean?
Mm-hmm. Absolutely. So I think even though it doesn't seem at first like there's much of a crossover, I actually think there's a huge link here between
Hmm.
our our people's health and sort of AI and consciousness technologies. And the reason is consciousness is basically who we are. It's what we experience every moment of the day. And that can go wrong in various ways. So we often think when we talk about health, we talk about physical health a lot, but then there's also a mental health component. And if you dive deep into it, what really is mental health? It's about how we're experiencing the world, how that makes us feel, and how there could be disorders associated with that as well. So I think researching consciousness is really, really important. It has huge applications in the future for our own human mental health, as well as thinking about the kind of minds of AI. We're really understanding the human mind. I guess there's two main areas where I think it will be really impactful. One is in trying to understand ways in which we can improve people's conscious experience in the future.
Hmm.
So there are various sort of many you could say there's a spectrum of like disorders of consciousness, if you like. So everything from
Hmm.
mild depression, where your outlook on the world, your experience of everyday life is just not that great. You're just not really enjoying it. You're not finding meaning in life.
Hmm.
From that all the way to like kind of serious disorders like severe schizophrenia and things like this are disorders of the way the world is being interpreted by the
Hmm.
brain. So I think by understanding how all that works, we can then come up with technologies or new approaches to actually help with that. So we have some of these approaches today. They're called meditation and
Hmm.
positive thinking. All these kind of we think of
Hmm.
them as tools where we can use our own mind to try and improve the state of our own mind. But what if in the future we could take that further and we actually have technologies that could sort of modulate or modify that directly? So
Wow.
you wouldn't have to go through, years and years and years of meditation training. There could just be some kind of technology, like something like a headset that you put on, and it will actually help train your brain. So
Hmm.
I think that there are some things there with healthcare, and then the other obvious category is our interaction with robots and machines themselves. So a lot of how we feel, our life is all about the systems we interact with, whether they're other people or whether they're technology, and we're interacting increasingly with technology over time. And I think things like how much time we spend staring at screens, how much time we spend on our phones
Yeah.
and on social media is impacting our health.
Hmm.
So maybe by having machines that have a more of a conscious component to them, we're sort of bringing back that like rehumanizing technology. And you could say, oh, that sort of sounds dystopian, but it's a
Yeah.
choice. It's a choice among options, right? We are interacting more and more and more with technology every day. So you could just
Mhm.
say, well, we have to stop interacting with technology, or we have to start rehumanizing that technology that we're interacting with. So I think there's a crossover there as well.
Yeah, that's fascinating. I mean, I can imagine obviously things like mental health disorders, as we know, we're at such early stages, primitive stages in many ways of even understanding
Mm-hmm.
what these conditions are, how to quantify them, how to treat them. It's such an unfortunate state, and obviously we also know that there's rising amounts of mental health distress
Mm-hmm.
across
Mm-hmm.
the world and in so many different
Yeah.
facets. I think changing our thinking about that, and even this idea that you mentioned of almost kind of modulating or kind of controlling various conscious states, how that could help people. I would imagine even who are in extreme states of transient distress, whether
Yeah.
through trauma or whether they're about to go through a certain situation or they can't get out of a certain PTSD type situation.
Mm-hmm.
Could there be
Mm-hmm.
things that are done to be able to,
Yeah.
I guess, almost dissect the consciousness even? I can
Mm-hmm.
also imagine, my gut feeling is that, as the research goes in the space, we'll almost have an entirely new vocabulary and an entirely new way of even being able to speak about um, states of consciousness and qualities around
Mm-hmm. Mm-hmm.
consciousness. Is you
Yeah.
think that's fair to say?
Absolutely. So one of the things I'm really interested in is, can we develop like a mathematical language to describe qualia? Because when people talk about consciousness, they often describe subjective experience, but the only tool we have to describe it is language at the moment. So
Hmm.
someone might describe, a wonderful experience they had walking through a garden, the air was fresh, flowers smelled awesome, but it's like, okay, you can explain that, and then someone can maybe invoke the same qualia a little bit in their own mind, but it's not a very precision way of doing this. So I would love for us to develop new techniques to try and understand how to represent these qualia. And I say mathematically, but that kind of makes it sound analytical. But maybe
Yeah.
we could just have some sort of rich representation. Maybe it's like artistic. Maybe there's a
Hmm.
visual way we can depict qualia states that we could then use to send from one mind to another in the
Hmm.
future. So I'm really interested in that idea of, all we have at the moment to describe these rich inner complex states is words. And words are just
Hmm.
symbols, and they're really not capturing that kind of underlying essence of what's going on. But maybe in the future we can come up with some better ways of doing that.
Yeah, and as I think about this more, we also think about how, we have a deepening understanding right now of the mind-body connection in
Mm-hmm.
general across disease states. Whether you're getting a diagnosis such as cancer of some kind, or let's say even in the context of things like our digestive and gut health and the interaction that happens with the human mind, I can only imagine this could open an entirely new field of therapeutic modalities
Mm-hmm.
that treat even other conditions that you wouldn't directly otherwise associate with quote
Yeah.
unquote your consciousness because you're able to reduce suffering or you're able to perhaps deal with complications of IBS
Mm-hmm.
or so forth by interacting with the consciousness
Mm-hmm.
directly. So yeah,
Yeah.
it's
Yeah.
obviously no pun intended, but mind bending.
Mm-hmm.
Couple of additional questions I wanted to explore. Obviously, I know it's too early to say because there's many
Mm-hmm.
questions to be answered before we get there, but do you imagine a reality in which we could actually move consciousness from one being to another, from an organic to an inorganic state as well?
Mm-hmm. Mm-hmm.
Um,
Yeah, I think I see what you mean. So this, again, this gets very sort of philosophical, and it depends really on your outlook and your philosophy and your metaphysics almost. But the way I think of it is, I think of a being. Now, it could
mhm,
be a human being, it could be a kind of robotic being, or an animal. I think of a being as having three components to it. So there's a consciousness, and then there's a physical body, and the information from the physical body goes into the consciousness. But there's a part in the middle that is sort of like all of your memory and your understanding of self and who you are. And some kind of meditation teachers call this the ego story. and I guess
Mhm.
some like psychologists as well. Like I'm sure Jung and Freud would would like
Yeah.
talking about this stuff too. But you build up over time as you live your life. You build up this kind of like you amass this knowledge, all this stuff that you think of as being yourself. And that's like your
Mhm.
life history, your story, your personality, all these things. So I think of that as being like a filter between the physical world and your consciousness. So imagine your consciousness is like a little like an observer looking through with a
Mhm.
telescope, and then there's all this stuff in the way, all this like ego story stuff, and through all that you see the real world. So the reason this is important for your question is when you say, could you move it to a different substrate or a different, place, that it's like,
Yeah.
what are you actually moving? So are you
Mhm.
moving all that knowledge of who you are, your history, your memories, yourself? Or are you
Mhm.
actually truly moving consciousness? And so I don't think consciousness truly moves. I think consciousness is something that's sort of more fundamental and it acts through people. So think of consciousness as more like your brain is more like a receiver of
Mhm.
consciousness, and then it's filtered through all the circuits of self that you've built up, and then it
Mhm.
acts on the world and becomes something that looks like you. So say you wanted
Mhm.
to make a digital copy of me, what would you have to
Mhm.
do? So you maybe have a body that kind of looks like me, maybe a robot body or something. You would then connect
Mhm.
that to a classical AI system that had learned or had a copy of all my memories, all my history, all what it means self-wise to be me. And then if you wanted to, you could run that thing and it would have behaviors like me from what I'd learned over my lifetime. But if you wanted to make it conscious, you'd have to connect it into that deeper layer of consciousness. And that's where I think the quantum part comes in. So it's a little bit of a
Mhm.
long-winded answer to your question, but I think you need all three things, right? If you want
Okay.
to create like a copy of someone.
Mhm.
Yeah. Now you
But
could create a low fidelity copy of them just with the classical AI and the body, but if you want to
it's those
make
two
it
pieces.
truly, yeah, you need the consciousness
Yeah.
component too. Yeah.
So, obviously to be explored and to be determined, but I guess hypothetically, if you did have those other two pieces and you
Mm-hmm.
were able to create that digital and physical twin, then, you know, if these questions get answered in the context of quantum consciousness, there could be the ability to then maybe not the exact same consciousness, but recreate specific components of that consciousness that either duplicates that or that mimics that or mirrors that into this other entity as well. That could
Mm-hmm.
hypothetically
Yeah, that's right.
be a possibility.
Yeah, I think you could do it hypothetically if you had the technology to kind of implement the consciousness part,
Hmm.
which is where my current hypothesis is that it might be quantum. So I'm open minded to this, but that's like what I'm working with right now. But maybe it's not. Maybe it's some physics we don't understand yet or don't know about yet. But I think you have to connect your AI and your kind of like body layer into whatever that thing is. So
Hmm.
until you do that, what you will have is you'll have a copy of the person, but it will be kind of like an interactive autobiography. This is the
Hmm.
best way I could imagine it is you have like maybe say a digital avatar of someone like me, and it's
Hmm.
behaving like me, it's sounding like me, but it's doing that because it's been trained on data from me, my real
Yeah,
version. It's just a
yeah,
mimic. It's like a kind of like
yeah,
a zombie version of me.
yeah, yeah.
And that might be great. Like maybe people just want to chat with this kind of mimic version of
Yeah.
me and it doesn't matter. But that thing, I don't think that thing is having any experience. I don't think it's having new conscious experience. I don't think it's aware. And I also think you'll be
Hmm.
able to push it right to the edge of creativity and see that it's sort of failing. It's lost some characteristics of me that come from
Hmm.
the pure consciousness part.
Hmm. Yeah, definitely a lot of intersections with Black Mirror, and
Yeah.
I don't know if you watched that series, but many episodes
Yeah,
obviously talk
I've
about
seen some of it. That's right.
yeah, there's this one episode that I was thinking about in kind of preparing for our conversation, which was the San Junipero episode. I think
Mm-hmm.
it was from the last season where these people who have they're at end of life, and they're going through difficult diagnoses and experiences, but they put on the system and their mind consciousness, whatever you call it,
Mm-hmm.
goes
Mm-hmm.
to this. fantastical other place where
Yeah.
they're able to live youthfully and experience a very different reality from where their physical body is located. And that's obviously kind of a
Yeah.
fascinating idea
Yeah.
with lots of implications. The last question I wanted to close things off on, I'm cognizant of time, was something you briefly touched on. It's a little bit tangential to the healthcare conversation, but I think an important one here was kind of your mentioning of how your work and in your career journey you've kind of moved from this materialist atheistic view of what's happening in the context of AI and in the context of consciousness. Are you able to speak a little bit more about that and how that's influenced your work at Nirvana Cat?
Yeah, absolutely. And actually, maybe I could tell that story through a kind of healthcare lens almost because it's
Yeah.
relevant. So, really, what happened was back in, it was like 2015, 2016 era, I started having major anxiety disorder. And
Hmm.
I was having a lot of like panic attacks. It was really difficult kind of to deal with. And so I went to the healthcare system and I said, you know, what can I do? I want to try everything. So I got prescribed SSRIs, and I was like, okay, this is not enough. I want to try everything. So I changed my diet. I started doing lots of different things, and I also started looking into, is there anything I can do like relaxation wise? So I got into meditation videos, and it started with something called sleep hypnosis videos, which is kind of the same as guided meditation. It's supposed to put you to sleep because I couldn't sleep, right? I was lying there
Hmm.
like having these like panic attacks, so I couldn't sleep. So I was trying to find ways to sleep, and then I got into that. I really got into meditation at that point. And so the deeper I went into the meditation journey, the more I started thinking about my own mind and what's going on here and what is consciousness, what is awareness. And at that point, that's where I really started to become open-minded to some of these ideas that the mind is not just a bunch of zeros and ones computing, like the analogy we have of the computer. There's actually something deeper or something else going on in there. And a lot of
Hmm.
people in the meditation or spiritual or religious communities would call this like, well, you're obviously connected to some kind of higher power. There's a God or some kind of source that we're all connected to. So I started taking some of those ideas seriously.
Hmm.
Before I was sort of like poo poo them and say, oh, that's just sort of spiritual new age nonsense.
Yeah.
I was very brought up with a very like scientific
Scientific
analytical
mind. Yeah.
training. But then I think what clicked for me is I thought, well, science doesn't have all the answers. It went back to the
Mhm.
story from school where I realized that there was this question that these amazing scientists hadn't answered yet. So that got me thinking maybe we should start taking seriously what, I don't know whether it's 70 or 80% of the population think more
Hmm.
along these lines of us being connected to something deeper. And in physics, there's this idea of we still haven't figured out the final theory of everything. Like how everything
Hmm.
in the universe connects to everything else, we really don't know. And so it leaves open the door that maybe there's a crossover or a bridge between the worlds of science and the worlds of spirituality, where there really is something that connects us all together. Now, if you're a
Hmm.
physicist, you might think of that as a quantum field. If
Yeah.
you're a spiritual person, you might think of that as God or a source or
Yeah.
spirit or something like that. But I think these
Yeah.
two camps, which often fight, are actually saying the same
The
thing,
same
just
thing.
using different
Yeah.
words. So that's really
Yeah.
what like opened my mind to some of these ideas. Is that when you look deeply, science is actually not incompatible with religion and spirituality at all. It's just they're talking
Hmm.
different languages, and so again, diving into consciousness, you cannot avoid that
Hmm.
intersection. You're like right in the middle of it. And I
Yeah.
sometimes find that it's like you get the worst of both worlds because now your previous group of scientist friends now think you've gone completely crazy because you started talking about like your consciousness being connected to the universe.
Yeah.
And then the spiritual people are still very skeptical of you because they're like, oh, well, you're just analytical, you just want to build AI, and
Yeah.
that's not that's
That's not spiritual. Yeah.
so you kind of get it from both sides. But I'm okay with that because I want to try and build bridges between those two communities. I think it's
Wow.
worthwhile.
That's that's hugely fascinating, and I think it's so temporally relevant right now, just in terms of where the human experience really is today. Where in many cases, we have replaced kind of the role and the presence that spirituality or religion
Mm-hmm.
played in our lives, we've replaced that with, unfortunately, many cases more of a consumerist
Absolutely.
kind of
Yeah.
almost religion, if you will. And speaking not with my clinical hat on, but I do feel like a lot of our existential distress and mental health and
Mm-hmm.
even physiologic distress is connected and or worsened by the fact that we aren't really anchored to anything that we can believe in.
Absolutely.
And in
Yeah.
certain ways, the rational thinking has been positioned as being an antithesis
Mm-hmm.
to spiritual thinking.
Mm.
But I appreciate your willingness to kind of to share that personal experience as well, because I think it's hugely important to destigmatize that. I
Mm-hmm.
know a lot of
Yeah.
people still have a hard time talking
Yeah,
about
and a
that,
lot of
and
entrepreneurs
thank
go
you
through
for sharing that.
this as well. It's
Yep,
very common in the satellite business world, especially in the high tech world where you've
yep,
got to move really fast and you're told to just, you know, work 18 hours a
yep,
day or whatever, and it's not good for you, and it's not the right way to do things in the long run.
yep, yep. No, for sure. Um, well, listen, Suzanne, I'm cognizant of time, and I really enjoyed this conversation. There's so much to tease apart here and to think about more and reflect on. I'm definitely going to enjoy listening to this again, and I think this is really going to be something meaningful for the audience of the podcast. I
Mm-hmm.
want to thank you again. I'm really excited to continue to follow along your work, and I'll make sure that if there's ways in which people can find out more about what you're doing, we'll ensure to post some links
Yeah,
and allow people to follow
absolutely.
along.
Yeah, well, thanks very much. This has been a really great conversation, really thought provoking, and thanks for the opportunity.